Okay, today we're going to do the normal approximation to the binomial distribution. So if you kind of remember the binomial distribution, that means that there's two outcomes that are possible and a fixed number of trials. So let me find my mouse again. No, okay. So a normal distribution is often used to solve problems that involve the binomial distribution, since when n is large, the calculations are too difficult to do by hand using the binomial distribution. So we just get lazy as math people. So you need the shortcut. That's basically all it is. So then we're going to use this normal distribution. That way we can convert everything to z-scores and find everything pretty nicely. So then the normal approximation to the binomial distribution is appropriate when NP is greater than 5 and NQ is greater than 5, greater than or equal to 5. So remember, N is just the number of trials. P is the probability that it's going to happen. Q is the probability that it's not going to happen. So those are the opposite things. So remember in our problems, we were given P and we had to find Q, which was just 1 minus P. Whoops, wrong clicker deal. Okay, in addition, we have a correction factor for continuity may be used in the normal approximation to the binomial. So what that basically means is when we do binomial distributions, if I was doing a dice, I don't know, a dice is a bad example. Okay, I'm just going to draw some random graph that has absolutely no word probleminess. Okay, so this would be, kind of what the binomial distribution would actually look like. Okay, in that it's actually discrete. We can make like a histogram of this is like 1, 2, 3, 4, 5, 6, 7, I don't even know where my 8, 9 is. Okay, so 5 is my middle of 1 and 9. So that would be my mean. So what happens is that maybe I can only get a 5 or a 6, but with the normal curve, remember normal curves, things that usually fit in there can be measured, not counted. Binomial things can be counted, so we have to have a correction factor so that I can have those in between pieces. Okay? The continuity correction means that for any specific value of x, say 8, the boundaries in the binomial distribution would be 7.5 to 8.5. So it's just back to using those boundary pieces. Okay, so we're just going to say, oh yeah, that's 8. Okay, so if I have, this didn't work out very good. When finding P of x equals some number, we're going to use that A minus 0.5 and A to plus 0.5. So we'll have to find 2 z-scores basically, is all that really means. Okay, if it's greater than or equal to that number, we will subtract 0.5 from it, and then we'll go ahead with it normally. Okay, so you'll want these all handy. So if it's strictly greater than, we will add 0.5. Okay, so there's a lot of little tiny differences in here, so make sure you get them all down right. If my probability is less than or equal to a value, I'm going to add 0.5 as well, but then it'll be, the signs are different, so make sure you're paying attention to the signs. If it's strictly less than, I'm going to subtract 0.5, but it's different because the signs are different than that one up there. No, I'm not. I know, it's taking a long time. My mean is still just NP. My sigma is still the square root of NPQ. My standard deviation. The first thing to always do is test your NP and test your NQ. Make sure those are greater than 5, because if it's not, we say the normal approximation does not work for this. Okay, so why it doesn't happen is you would have a very small n or a very, very tiny p or q. Me too. Nice. Is this like the first time you guys have like gone to state in something in the last few years?
Yeah.
I was gonna go look and see that.
Oh, two? Because I mean, like, I don't remember ever getting a half day for anything. And it's nice. I like it. I don't know if these are in your book on a certain page. Okay, these are also on page 342. This is not a very good marker either. And it's that there's a couple different little block thingies, and this is one of them. Okay, do I have my calculator handy so that we can all do calculations together? Okay, now I can change it? We're good? Okay, maybe, if I find it. Maybe again. Okay.
From last season to this season has gained 50 pounds.
That's scary. See, that's what you need to do, Tara. You should have been gaining weight all this time. Okay, so first thing we need to always do, check whether the normal approximation can be used. Remember, that's the NP greater than 5, NQ is greater than 5. Okay, find the mean and the standard deviation, because we'll need that. So that's N times P, NPQ square root. So that should have been written down from the last thingy. Okay, write the problem in probability notation using X. Rewrite the problem using the continuity correction factor, which is that last page that was, let me kind of go back and show you what that means. Where's my mouse? Seriously. I'm losing everything, you guys. Okay, so this is in the probability notation. This is the correction factor. Now let me go back, find it again. Okay, so write it with the probability, write it with the correction factor. Do I need to stay on that? No, we're good. Okay, find the corresponding z-values. Okay, sorry. After we do these pieces with the probability notation and then the correction factor, pretty much just says the correction factor.
Oh, okay. Never mind then.
Yeah. And then step 5 is find your z-scores. 6, find your solution, wherever those z-scores would be. Okay, so let's do one of them. So example 616.
What was 6? Let's find z-scores and then...
Find the solution, I believe. Find the solution, yeah. So this is a weird problem that people used to do. I don't think people read and drive anymore. Have you guys ever even heard of people reading and driving? Like before texting and driving, like I totally used to read and drive. And then like texting became this big deal, and then it was like, oh, we can't be distracted while we drive. People were always distracted while we drove. We just weren't. I don't know. It's just, it didn't cause that many accidents because not very many people did it. Okay? So a magazine reported that 6% of American drivers read the newspaper while driving. If 300 drivers are selected at random, find the probability that exactly 25 say they read the newspaper while driving. Okay? So our N is what?
Was your N 300?
Yep, my N is 300. My P is what?
25?
Nope.
The opposite of 25?
No.
6%?
6. So 0.06. What's my Q?
25?
No.
Point something percent?
Yes. What is that something?
6%, so 94%?
94. So make sure you're comfortable finding those P's and Q's.
So what's up with the 25 then?
25 is what we're going to have as our probability notation. Probability that X is exactly 25. Okay, so that's where we're going to use that piece of it. First thing we're doing though, remember it says, or let me read the steps. Check to see whether the normal approximation can be used. That's the N times P. So first thing we need to do is N times P, which is 300 times 0.06. What do we want it to be greater than? 18. So is that okay? So what does that number have to be bigger than in order to use this? Okay, so it needs to be greater than 5. Remember, that's how we're testing it. Okay, so hey, it's greater than or equal to 5, so that one's okay. Now I'm also going to have to do n times q, which is 300 times 0.94. Hey, that one's definitely going to work out. It's 282. So that one is greater than or equal to 5, so we're good. We don't care what it is. We just need to make sure it'll work. Okay, then we've done find the mean and the standard deviation. So how do we find the mean again? It's pretty short.
We added all up and divide?
Much shorter than that.
300?
No. It's just our p times n.
Oh.
Okay, we've already done that, and it happened, so I'll write it out again. N times p, we've already done 300 times 0.06 is equal to 18. So that's our mean. I'm just going to write it out a little bit nicer so I don't have to look for it anyway. Then how do we find our sigma, our standard deviation?
Don't you have to do the variance first?
Yeah, we have to do the variance first, so what's my variance?
So your variance would be 18 squared, isn't it?
Nope.
The square.
Okay, when we're doing normal approximations or normal anything, it's just going to be NPQ. Okay, so in this case, we haven't done this one yet. So 300 times 0.06 times 0.94. I don't know what that is. 1692. Okay, so that is, whoops, not that point, there's a point in there. Okay, so that's my variance. So now my standard deviation is just the square root of that. So just my plain old sigma without a squared on it is 4.11. Okay. So I have my mean and my variance, or my mean and my standard deviation. So we've already then, so this is step 1. This guy is step 2. Writing it in probability notation, this x equals 25, that's actually step 3. And then the fourth thingy in there is rewrite the problem using the continuity correction factor and show the corresponding area under the normal distribution. So then that means on that big long thing you wrote down that I am really doing the probability. So this little guy is my A that they have in there. So it's the probability that 25 minus 0.5 is less than x is less than 25 plus 0.5. Okay, so we spent a lot of time on that earlier, and you're like, oh my god, what is the point of this? I know how to add and subtract 0.5. Now it's actually kind of a little more useful in that we're turning it into those z-scores after that. Okay, I don't really need to actually write this step out. I can really just go in and say, oh, that's 24.5 less than x less than 25.5. Let me make sure, did you guys check to make sure I had all my signs the right way? Okay, so that's the biggest thing, is making sure the signs are the right way. And if you notice on that continuity correction factor that none of those little signs, when we wrote it like this in the big long ways, none of those had little equal signs underneath. Okay, that's because we can't find the equal sign on our little chart thing. That is definitely misplaced again. Okay, everything that we can use our z-scores for are strictly less than or greater than. There's no equal to signs on this chart because that would be gross and we don't want to think about that much stuff. Okay, so also the matter of it is just finding it with those signs. Okay, so what that guy is going to look like, so that's our fourth step. Now it is find the corresponding z-values. So how did we find z-values again? Are you guys just dead today? Okay, so my z values are going to be, I'm going to have to do a z value for each separate thing. So my z values will be the number minus my mean over my standard deviation. So 24.5 minus my mean of 18 over my standard deviation of 411. Okay, whatever that dude is, so make sure you're typing it in right. I guess I really didn't have to record this today, but oh well. Is 1.58. And then I am finding my z-score of my other thingy. And make sure you round properly. This is really 1.581. Let's make sure you got that down. Then I'm doing 25.5 minus 18 over 411.
That's so weird.
What?
The girl from Mississippi, today I found out my school is still considered legally segregated. And now we're trying to prove to the courts that we have sufficiently integrated. That's so weird.
How does that even happen?
I don't know. And the chick from
Are there
Arizona was
black
like,
kids
how
there?
could they have just discovered that now?
Are there black kids there?
I think so.
Are there not enough proportionate black kids to the area?
I don't know.
That would be the only thing that I would think of. So this is 1.824, so 1.82.
The girl from Arizona, how could you just find that out now?
They don't want to. They don't care. They want to say racist down there. Okay, so those are my z-scores. Now I need to find the probability of z-scores between that. So if I draw my real quick graph so that I can kind of visualize it, 18 is my middle. I have 24 and 25 over here somewhere, and I need to find that area between it. Okay, so this is a z-score of 158. This is a z-score of 182. So I need to go in and find those actual probability values for each of those things. Okay, so the probability that it's less than, I'm going to try to write it out a little bit differently. So it's the probability that x is basically less than 182. And then it'll be minus, this is gross. I haven't really written it out like this before, so I don't know if you want me to or not. X is less than 158, and then we're subtracting those values. Okay, so 182, they're both positive, so I'm on the right-hand page, my little chart deal. I wonder what happened to my video thingy. It disappeared. So I have 182. 182, I have 9656. Remember, I have a point in there. Minus 158, so I have 1.5 over to my 8. I have 9429.9429. Okay, subtract whatever those values happen to be. You got that one? Point 0.0227. So then we could, so that's the probability. We need to go back and kind of make it make sense according to the problem. So it would read something like, if 300 drivers are selected at random, the probability, so we're going to kind of get rid of fine, the probability that exactly 25 say that they were reading the newspaper while driving is about 2.27%. We can change it to percentages. Or you could leave it like that, 0.02 or 0.0227. So either way, just kind of make that make sense back into the problem.
So, 2.27% said that they would be caught reading.
No. It's the probability that 25, exactly 25, will be caught reading.
Okay, so the 2.27% probability that 25 will be caught.
Yeah.
That seems long.
Yeah.
Is that it?
Yeah.
Are we doing another?
I was planning on doing another one. How do you guys feel? You want just that one? Just that one? Okay, then you guys can do, yep, and 'cause there's just one more after that, I think. Yep, so, numbers. Okay, and that was strictly just like the equal to one, but I think not all of them are gonna have to find two z-scores. So when it's equal to, that's when you have to, which kind of seems stupid, but. Let's do one through three. Can you see this? 1 through 3, and
Yeah. 5 through 7.
5 through 9. Oh, let's. Yep, we're calling it good.
Ooh, 5 through 9. Odd.
Yeah, there's only 14 problems. So you guys always think I'm trying to be nice on these days, but no. Okay, so you're done recording? Are you gonna be done recording?